Hi, my name is Miss Fung. Let's have a look at arrangements in combinatorics. Here we have the example from a previous video where Ella is very hungry and is trying to decide what to order from a menu that contains 5 mains, 3 desserts and 4 different types of drinks. In today's video, we're going to look at different types of questions, such as how many choices does she have if she has a main, a drink, but she can't decide whether she's going to have a dessert or not. So for the main, she has 5 choices. For the dessert this time, she can have 4 choices: tiramisu, cheesecake, ice cream, or no dessert. Not having a dessert is a choice. So to answer the question, we have 5 times 4 times 4 for the drinks, which is 80. So when you have a choice of not having something, count that in as a possible choice. What about if we asked, what if she chooses one main and one of either dessert or drink? So one main would be 5, and means times, a dessert or a drink. So dessert or drinks means we're adding the dessert and drinks together. So 3 plus 4 is 7. So we have 5 times 7. I'm going to say that again one more time. So she chooses a main, and that's times, dessert or drink. Or means plus. 3 plus 4 is 7. So we have 35. Example 3. How many number plates are there that start with 3 letters and ends with 3 digits? So 3 letters and 3 digits. So you can have between A to Z for the letters, and then you can have 0 to 9 for the digits. How many letters in the alphabet? Well, there's 26. So you can have 26 and 26 and 26. And then for 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 digits. 10 digits and 10 digits. So you have 26 and 26 and 26 and 10 and 10 and 10. So multiplying all that together, we get 17,576,000 possible number plates. What about if we had the same questions, but this time each digit and letter may only be used once? So the same setup, we have 3 letters and 3 digits, but now the letters, every time we use one, we cannot use it again. So in the first box, we could have 26 different letters, but in the second box, we only have 25. And in the third box, we can only have 24. Same with the numbers. In the first box, we now have a choice of 10 different digits. Once we use one, we can't use it again, so we have 9. And in the next box, we only have 8. So if we only had to use the digits and letters once, we would only have 11,232,000 possible number plates. Example 5. How many 5-digit even numbers can be made from 1, 2, 3, 4, 5, 6, 7, 8? Whenever we see these questions, always put the restrictions first. So what does even mean? It means we have to end in an even number. And the other 4 digits can be anything between 1 and 8. How many choices do we have for even? We can have 2, 4, 6 or 8. We have 4 choices. And then in the other digits, we have 1 to 8. So we have all 8 digits to choose from. So when we multiply these, we see that we have 16,384 different 5-digit even numbers that can be made from 1 to 8. What if we had the same question, but we can only choose each digit once? So again, start with the restriction, and we have 4 values we can put in as the last digit. We can put 2, 4, 6 or 8. And now that we've used one of the digits, how many digits do we have? We only have 7 left. And after we use that one, we only have 6, and then 5, and then 4. Multiplying these, we obtain 3,360. Last example, and this one's going to be a super hard, challenging example. How many 3-digit numbers greater than 700 that have 2 identical digits can you make? So 3-digit numbers. Always consider the restrictions first. What are 3-digit numbers? Starting with 7. So greater than 700 means starts with 7. And 2 of them have to be the same. So we can have 7, 7 and something that's not 7. So we only have 1 7, we only have 1 7, and not 7 mean we can have 0, 1, 2, 3, 4, 5, 6, not 7, 8, 9. So we have 9 options over there. We could have something starting with 7, not have a 7 there, and then end with a 7. That would make 2 things that are the same. Again, for the 7s, we have 1 option, not a 7, we have 9 options. But we could also start with number 8, so 8, 8 and something else. And for 8, we only have 1 option, but not 8 would be 0, 1, 2, 3, 4, 5, 6, 7, not 8, 9. So again, it's 9 options. And we could have 8, not 8, and 8. So that would be 1 option, 9 option, 1 option. But we could also have the 9 with the similar pattern. We also have to consider if we have starting with 7 and the 2 other digits to be the same. But it has to be greater than 700. So the other 2 digits cannot be 7 and cannot be 0. So 7 we have 1 option, but not 7 and not 0. That means 1, 2, 3, 4, 5, 6, not 7, 8, 9. So we can only have 8 options for the not 7, and whatever that is, we can only pick the 1 digit that's exactly the same. So same thing with starting with an 8 and not 8s. So we have, for an 8 we only have 1 option, and then not 8 would be 9 options because we can pick 0 this time. We can have 800, and not 8 again would be 1 option because it has to be the same as whatever number we picked there. And 9, well, to start with 9 is 1, not a 9 would mean the other 9 options, and whatever we pick there we have to pick the same value, so there's only 1 option there. So when we multiply across, we can see that 1 times 1 is 9, 1 times 1 is 9, so, and then this or that means we're adding them together, so it's 9 plus 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 9. Or in other words, there's 8 9s, so 8 times 9 plus that 1 8 over there, so we have 80. Let me know if you were able to answer the challenge question today. Thanks for watching. I'll see you next time. Bye.